Dear friends, in this video we are going to discuss some types of steam turbines and the compounding of steam turbines. So the introduction section we are seeing that the steam turbine which is a prime mover in large power plants where high pressure steam is converted into mechanical power directly in the form of rotary motion. From the boiler, steam is generated and high pressure steam will be impinging on the turbine blades through the nozzles. So what are the different types of turbines we have? Impulse turbine and reaction turbine. The operation of the turbine depends on the dynamic action of steam expanded through the nozzle. The steam turbine develops power from change of momentum of steam jet while passing over a smooth vane or blade. High pressure steam from boilers expanded the nozzle. Nozzles are used to convert pressure energy into kinetic energy. If you look at the diagram, you can easily understand that high pressure, low velocity, which is entry point, when it leaves the nozzle, it becomes low pressure and high velocity. This high velocity steam will be impinging on the turbine blades. So here we can see the projected view of the nozzle mounted on a set of rotor. Nozzle is fitted over the rotor mounted with a number of blades. Each blade is separated by 5 mm gap. The force produced by the change in momentum is known as impulsive force, which tries to push the blade in forward direction, but blades are not free to rotate, free to move, which is fixed over the rotor. So it will make the rotor also to rotate. The rotor is connected to the shaft, so shaft is rotating and shaft is connected to the power generator and we are getting the power source. What are the major components or major parts of steam turbine? Nozzles, wheel or rotor, vanes or blades and casing. Nozzle, we know that it will convert low velocity into high velocity, at the same time high pressure to low pressure. The impulse turbine, if you look at this simple video, that is when the steam is impinging on the turbine blades, it will make the turbine to rotate. That is, it makes the rotor to rotate, thereby making the turbine shaft to rotate. The turbine shaft is connected to the generator. This is an impulse reaction turbine. Previous one is the impulse turbine. Here it is a reaction turbine. Nozzle will move on the bearing in the opposite direction of the steam flow, and the pressure is not constant in this turbine. Reaction force is always applied on the nozzles and tubes. The resultant force produces to the rotor is the vector sum of impulsive and reactive forces, and the reaction force is in unbalanced condition. So if you look at this, we can easily understand that the steam which is coming from the boiler will enter like this, and the exhaust steam will be going like this. This is the casing. The entire thing will be inside. This is the diagram we have to understand. This is the expanded view, that is nozzle. See the look at the nozzle here. It enters and glide over, or the profile of the blade is here. So it glide over the blade and comes out. At the initial pressure is boiler pressure. We have to reduce the boiler pressure to the condenser pressure. This is called condenser pressure. This is called condenser pressure. This is called boiler pressure. So we have to reduce the boiler pressure to condenser pressure. If it is in a single stage, it will damage the rotor blades. Since huge pressure drop in a single stage is not advisable, it will damage the dynamics and rotating components. So we will prefer compounding of steam turbines, that is stage by stage reduction of pressure. See, look at this velocity at the entrance. This velocity at the entrance. This is a high pressure of the steam from the boiler. This high pressure. This is a velocity. So the condensing pressure, the pressure from here to here, it is equal to condensing. This is the low pressure. The velocity, leaving velocity is reduced. So stage by stage we have to reduce. That we will be seeing the next slide. That is compounding. There are three types of compounding: velocity compounding, pressure and velocity compounded turbine. See, this is a velocity compounding. In the velocity, this is inlet pressure, there is boiler pressure, this is the velocity, inlet velocity, this is the condensed pressure as you know. This is called the leaving velocity. This is called the leaving velocity. So the velocity is reduced in stage by stage. You see, from the nozzle, the steam is impinged on the moving blade and it glides over the fixed blade. There it drops some velocity and pressure is maintained constant between two rows. And again, the velocity is reduced, constant velocity reduced, and velocity fixed blade almost velocity is constant, and the leaving velocity is this much. In the case of pressure, it, it has a constant pressure line. The nozzle exit, the pressure will be same, whether it is moving on moving blade or fixed blade, moving blade or fixed blade. When it passes over the row of blades, the velocity pressure is maintained constant. This is called constant pressure, condenser pressure. This is called velocity compound turbine. The velocity is reduced stage by stage, whereas pressure is maintained at a constant level from the nozzle exit. This is another explanation for reaction turbine impulsive force. That is how this reaction turbine is a resultant of reaction force and impulsive force. This is called the velocity triangle. This okay. Now let us look at the differences between impulse and reaction turbine. In the impulse turbine, entire available energy of water is converted into kinetic energy, whereas in the reaction turbine, it is not so. The impulse, the water flows through the nozzle and impinges on the buckets, which are fixed to the periphery of the wheel, whereas in the reaction, water glides over the blades. The pressure of the flowing water remains unchanged and is equal to the atmospheric pressure. Pressure of the flowing water is reduced after gliding over the vanes. The impulse turbine has more hydraulic efficiency, but reaction turbine has relatively less. Impulse turbine operates at high water heads, whereas reaction turbine operates at medium and lower heads. Examples for impulse turbine: D-level turbine, Pelton turbine, whereas for reaction turbine, Kaplan turbine, Francis turbine are the examples for reaction turbine. So this is a simplified diagram of impulse and reaction turbine. If you look at the diagram, you can easily understand difference between impulse and reaction turbine. Here we have the moving buckets and fixed nozzle and the rotor. Rotor is the important component. Over the rotor only the blades have been fitted. So when you look at these moving buckets and fixed nozzles, how the steam is flowing. High pressure steam is reduced to low pressure steam. At the same time, when the velocity increases and reduces, when it impinges on the moving buckets, the velocity is increased. After that, velocity is reduced. In the case of reaction turbine, pressure is gradually reduced, velocity is increased, and it starts reducing. When it passes over the rotating blades, the velocity is reduced. When it passes over the moving blades, the velocity is increased. So this is the concept we have to understand. This is the pressure compounding, how the pressure is lowered in stage by stage. Nozzles at the blade fixed blade it is constant. Nozzle pressure reduces, blade it is constant. Nozzle reduces, blade it is constant. This is called pressure compounding. Already we have seen velocity compounding. This is a pressure velocity compounding. Both is happening simultaneously. This is called pressure velocity compounding. This diagram shows the pressure velocity, compounding, fixed nozzle, moving blade, fixed blade, moving blade, fixed nozzle, moving blade, fixed blade, and moving blades. This is two-stage pressure velocity compounding. So otherwise the blade, rotor, wheel, everything will get damaged. Sudden reduction in pressure will cause damage to mechanical components. At the same time, sudden decrease in velocity also will induce damage to dynamic components. Okay, with this we will close the comparison between steam and impulse and reaction turbine and compounding of turbines. Thank you for watching this video. Thank you.